In this video, we'll simplify expressions with negative exponents and fractions. There are a few different ways to do that, and I will show you one today, but in order to move on, the rules that I'm going to be using today is negative exponent rules. If the negative exponent is on the numerator, we move it to the denominator and change it to positive. If the negative exponent is on the denominator, we'll move it up to the numerator and change it to positive. So the change can be from the top to the bottom, change the power, or from the bottom to the top, change the power. Product of powers: if you have two bases to multiply of the same kind, you keep the base and add their exponents. And the quotient rule. So this is when we are simplifying expressions with negative exponents and fractions. Fractions are divisions, and divisions are quotients. So we're going to need the quotient rule. If you're dividing two powers with the same base, you keep the base and subtract the exponents. So this time we need our quotient rule with subtracting the exponents. To simplify each expression, we are going to still make sure that all the answers contain positive exponents. To organize our work in a chart, we're going to have example. We're going to use the rules to simplify, and the answer with positive exponents only. For the first example, I have n to the negative 2 and n to the third. This particular problem, if I was to use the quotient rule, I would say keep the base and then subtract the exponents. So that would be n to the negative 5, and then change it to the positive exponent. That would be 1 over n to the fifth. So if I was to use the actual quotient rule right away, I have to keep the base, subtract the exponents, and that's negative 2 minus 3, and then change the power to positive. There is another way to show this process or this kind of problem, how to solve. When it comes to fractions or quotients, I like to change the negative exponents to positive right away, and I found it simpler to simplify. That way you don't have to deal with negative integers, adding, subtracting negative integers. So it makes the process in a way simpler. So first I'm going to identify my negative exponent, and that is n to the negative second power. N to the third is not the negative exponent, so it stays where it used to be. But n to the second negative is on the numerator. So what I'm going to do is use the negative numerator and change it to the denominator to change its power to positive. So I'm going to move it down, that means to the denominator, and change its power to positive. What goes up is a 1. Here now we have n to the third plus 2. This is where we use the product of powers rule. We add the exponents, and our answer is 1 over n to the fifth, which is already an positive exponent. So I'm going to write it here. So if I look back at what I did before, using the quotient rule in the fraction, I keep the base, subtract the exponent, I have a negative 5, and change it to power of positive using the negative exponent rule. I have the same exact answer, 1 over n to the fifth. So there are two different ways that can be done in process of solving. I prefer changing the power to positive. That way you work with positive integers only. If you want to go with the quotient rule, then the answer will be the same. Let's see another example. M to the negative 2 and m to the fourth. So if I was to use the rule, I'm going to keep the base and then subtract negative 2 minus negative 4. So that will be keep the base, negative 2 plus 4, where m will be to the second power in my answer. So if I use the quotient rule, which I can, In the quotient, you keep the base, subtract the exponents. Make sure that you subtract -2 minus -4, where you have to use the integer rules, and that will be your answer. What I'm going to do is I'm going to use the changing the negative exponent to positive. So first, I identify my negative exponent. This is m to the -2. So that will go down to the denominator, because if I change, I need to change it to the denominator. And here I have m to the 4th, which is negative, so that one has to change up to the numerator. So what this fraction is actually is m to the 4th and m to the 2nd, because m to the -2nd went to the denominator and m to the -4th went up. That is what the rule says. If the negative exponent is on the denominator, then it goes up and changes the exponent. If it's on the numerator, then it goes down and changes the power to positive. From here, you can use your quotient rule with positive numbers only, where you have 4 minus 2, which is m to the 2nd, or you can use the expanded form to simplify the common facts, and it's still m to the 2nd. So now, the more ways we learn, the more options you're going to have to solve. Or m to the 4th over m to the 2nd, 4 minus 2 is still m to the 2nd. In the original example, when I used the rule to start from, we kept the base and subtracting the exponent, and we still got m to the 2nd. So there are a few different options for you to choose from. I'll keep going with changing the negative exponent to positive and simplifying, and I'll stay consistent from this example on. So for problem number 3, I have first, identify the base with a negative exponent. Everything else is the same. The 4, the 3, the x in the same exact locations. 4 is on the numerator, 3 and x on the denominator. The only factor that is moving now is x to the -2 to the denominator. This one is not there anymore. It went down to the denominator and changed the power to positive. So what we have now is 4 over 3 and x to the 1 plus 2. This way, I'm working with positive integers only, so I don't have the confusion of negative integers involved. That will be 4 over 3 and x to the 3rd power. And this is already an answer that has positive exponents only, and it is simplified, so that is my final answer. Let's see it again to observe the pattern. 10x to the 3rd positive over 15x to the -1. So the base with a negative exponent is x to the -1. Everything else remains in place. 10x to the 3rd, 15, and now this goes up to the numerator and changes its power to positive. So what we have is all positive exponents, and 10 and 15 can be simplified by dividing by 5. 10 divided by 5 is 2, 15 divided by 5 is 3. So we have 2, the base, x to the 3 plus 1, which is keep the base, add the exponents, product of powers rule, over 3. 2 is a numerical base. X to the 4th has a positive exponent. Over 3 is the denominator. Final answer. Another example to observe the pattern. So I'm staying consistent from now on with changing the negative exponent to positive and then simplify. So first I have to identify my negative exponents, and this is where I have x to the negative 3. The 4 is a numerical base, the 8 is a numerical base, and the x is to the first power, which is positive exponent. So I leave everything in place that did not have a negative exponent. So the numbers or variables that did not have negative exponent stay in the same exact locations. What happens to this fact is changing from numerator to the denominator and changes the power to positive. Now I see my 4 and 8 can be divided by 4, and I can simplify by dividing by 4. 4 divided by 4 is 1, 8 divided by 4 is 2. So that is 1 left on the numerator, 2 on the denominator, and x to the power 1 plus 3, that is when we keep the base and add the exponents because of the product of powers. If the exponent not shown, it is 1 there. So 1 plus 3 is 4, and that will be positive. 1 remains on the numerator, 2x to the 4th power on the denominator. And that will be my answer containing positive exponents only. In the next example, I'm going to have two variables, x and y. The process will be exactly the same. So first, I need to clearly identify which base has a negative exponent. Here, x to the first, positive exponent. Y is to the negative 2. On the denominator, 2 is a number base. X to the negative 3 is negative exponent. Y is to the first, which is positive exponent. So what I do first is I leave the x to the first, the 2, and the y to the first in the places they belong. So numerator and 2y denominator. Those were not affected by negative exponents, so they stay where they belong. Numerator on the numerator, denominator on denominator. Then this y had a negative exponent, so I'm going to move it down to the denominator and change its power to positive. This x had a negative exponent, so I'm going to move it up and change its power to positive. So from here on, x and x are the base that we keep and add the exponents. 2 is a numerical base, so we don't touch that. Y will be to the power of 1 plus 2. So I have only positive exponents. X will be to the 4th on the numerator, 2y to the 3rd on the denominator. Final answer. Number 7. First, clearly identify which exponents are negative. Not bases, which exponents are negative. So here I have negative 4, which is a number base. It is not an exponent. X is to the negative 2, which is a negative exponent involved. And on the denominator, x to the negative 3 is a negative exponent involved. The negative 4 is not an exponent, that's a base, so that one we don't touch. And then the 6 is on the denominator. So what I have is negative 4 and 6. Those stay in the same places because they are not affected by negative exponent. The x to the negative 2nd is going to come here, and the x to the negative 3rd is going to go up and change its power to positive. Now my exponents are positive. So from here, I can subtract 3 minus 2, and that will be x to the 1st on the numerator, or I can divide using the exponent rules. I'll show you dividing by 2. So on the numerator, I have negative 2 simplified, and you can go like this, x times x times x, and here we have 3 and x times x, and simplify the common facts. Either way, we have 1x which is 3 minus 2, 1x, still on the numerator because on the numerator the higher power. So I have negative 2x on the numerator over 3. The exponents are positive. Or from here you can just simplify the fraction and then use the quotient rule. 3 minus 2 is 1, and it is higher power on the numerator, so the x is on the numerator. Let's see another one with two variables like this. First, identify the negative exponents. Negative exponents are x to the negative 1 and y to the negative 2. How about this negative? That one is not for negative x. That one is a negative 1, which is a base that is a number, or the hidden coefficient, negative 1. So that negative 1 does not belong to the x to the negative 1. They're two separate things. So leave the negative 1, leave the y, those were the only two that are not affected by negative exponents. Here, this x to the negative 1 will come down to the denominator. X to the second will go up, and y to the second will go up. So here we go. X to the negative 1 has to go down here. Change the power to positive. X to the negative 2 has to go up. Change the power to positive. Y to the negative 2 has to go up. Change the power to positive. This is where I would use the expanded method because it's more visual. Or you can combine the y plus y, and that would be y to the first and y to the first. 1 plus 1 will be y to the second. Or you can use here the 2 minus 1 quotient rule. What I'm going to do, I'm going to write it out. So negative 1 times y times x times y over x. One of the x's can be divided with one on the top with one on the bottom. Simplify x by x. And then we collect back what is left. Negative 1, y to the second power, and an x. So I have to put them all in my answer. Negative 1, x, and y to the second power. Over 1, which is the same thing. One more example. Negative exponent is affected right here where your x is to the negative 4. The 2 and the negative 6 are numerical bases. So again, negative 6 is not an exponent. That does not affect any move or change or rule that is related to negative exponents. So 2 remains, negative 6 remain. What happens here is you're using the negative exponent rule, and if the negative exponent is on a denominator, we move it up to the numerator and change its power to positive. 2 and 6 can be simplified, divide by 2. So what you're going to have is negative 1/3 and x to the 4th is on the numerator. If I multiply x to the 4th times 1, this answer can be written as negative x to the 4th over 3.